Hey, all, today we're going to continue talking about equations of lines, and this time we're going to talk about relationships that two or more, but in this case, two lines can have. And two of those special relationships that they can have are lines being parallel or being perpendicular. And this might be something you have experience with, but if not, that's okay. That's what we're here for. So what we need to know is that parallel lines are two lines that never cross. So parallel lines are two lines that never cross. Even if these two lines kept going on and on forever, if they were parallel, they would never cross. Perpendicular lines, they make 90-degree angles when they cross. Ninety-degree angles are right angles. Maybe we could call them square angles, but that's what makes them perpendicular. So parallel lines are two lines that will never cross each other. Perpendicular lines cross, they only cross once. Lines can only intersect one time, but they make these special 90-degree angles. Any other relationship between the two lines is going to be that the lines intersect one time. They just make some sort of other angle. And so when we get equations of lines, what we want to determine is if the lines are parallel, if they're perpendicular, or if maybe they just intersect in some non-unique way, which we would say neither. And so what's really nice is we can look at the slopes of those lines, and we can decide using the slope if those lines are parallel, perpendicular, or neither of those two things. Parallel lines have the same slope. So parallel lines have the same slope. That means if two equations have the same slope, then those lines are parallel. For example, use the same color. If I look at these two lines, they're in y equals mx plus b form. So the number in front of x is my slope. So the slope of this first line is -1/4. The slope of my second line is also -1/4. That means these two lines are slanted the same way. And because they're slanted the same way, they're never going to intersect, and that makes them parallel. So let me graph these two lines. I have to zoom out a bit. This red line is the first line. The blue line is my second line. You can see there, I can drag this graph forever, and these two lines are never going to intersect. That's because they're slanted the same way. If they're slanted the same way, they're never going to get closer to each other. That slope, -1/4, is what tells us about how slanted they are. And so because they have the same slope, those two lines are parallel. So these two lines are parallel. And we do have a symbol we use sometimes for parallel, and it's just these kind of two slanted lines together. Perpendicular, much like the name, is slightly more complicated. Perpendicular lines, they have slopes that are flipped fractions. So one slope looks like you flip the fraction of the other slope. And then they have opposite signs. So one is always going to be positive, and one is always going to be negative. So one will be positive, one will be negative. So one line is always going to go up to the right, and one line is always going to go down to the right. So if I look at these two lines, again, they are in y equals mx plus b form. So we can go find the number in front of x. The slope of this line is 4, which is the same as 4/1. The slope of this line is -1/4. which is right here. And so you can see that 4 over 1 is the opposite or flipped from 1 over 4. They're flipped. And this one is positive. 4 over 1 is positive, and negative 4 over 1 is negative. And so they are flipped fractions, and they are opposite signs, and these two lines are perpendicular. And that is our symbol for perpendicular, the upside down capital T. So if I were to graph these lines, and I believe one of them is the same as the blue one, so I'm just going to go change this one to 4x plus 12. If you look at these two lines, they cross one time. They cross right there. There's a point there. And it looks like they make these square right 90-degree angles. They make perfect corners where they intersect. So 4 perfect corners, sort of like the corner of a room. And that is because they are perpendicular. So we can just look at slopes and decide if lines are parallel, perpendicular, or if they don't have either of those relationships, then they would intersect, but they would not be parallel or perpendicular. You can always check your answer by graphing the lines to see if they look like they're parallel or perpendicular, but you should use the evidence of the slopes to really say which is which. So if my line is in y equals mx plus b form, like the second one is, we can just go pick the slope right away. But if it's not, then we need to convert it to y equals mx plus b, meaning we need to take this first one and get y all by itself. So the first thing we're going to do is move 7x over here. And since it's kind of like adding 7x, it's going to become minus 7x. And then this 25 is positive, so it's plus 25. And then we're going to move this minus 5 over. Since minus 5 is multiplying y, we are going to divide everything by minus 5. So it's going to change its operation and become division. Negative 7 over negative 5 is positive 7 over 5. And then we have minus 5. And so the slope of this line is 7 over 5. So we have 7 over 5 and negative 5 over 7. Those two are flipped fractions. If you flipped one of them over, you'd get the other one. And they are opposite signs. One's negative, one is positive. And so these are perpendicular. And it's good to know both the symbol and the word. Same idea over here. We got to change these to y equals mx plus b form. So I'm going to start by moving that minus x over. It's going to stop subtracting and it's going to add. So it's going to be positive x. For this one, I'm going to move that minus 4x over. It's going to be positive 4x. And this is stuff we've done in the past. So if you're struggling with this part and I'm going too fast, just please ask me for help. 2 is multiplying y, so I end up dividing these things by 2. And I get 2x and 2. And so I'm going to look at the slopes. The number in front of x here is 1, even though we didn't write it, so the slope is 1. The number in front of x here is 2, so my slope is 2. They are not the same. They're not flip fractions. They're not opposite signs. And so these lines will cross each other, but they will not make right angles. And so we would say these are neither parallel or perpendicular. They're neither of the two. They're just two lines that will intersect somewhere, but not in a special way. And let me do one more. This one is already in y equals mx plus b form, so we can say the slope of this line is 3. For my top one, I'm going to move the 9x over. That's minus 3y. Plus 9x becomes minus 9x. And that 9 is positive, even though we didn't write it, so it's plus 9. -3 is multiplying. So when I bring it over, it's going to divide each of these things. -9 divided by -3 is 3. You can use Desmos if you need to, and that's -3. And so the slope of this line is also 3. These two slopes are the same, and so that makes them parallel. So before you move on to the you try problems, the ones where I want you to pause and give them a try, if you have any questions about this, please ask first before you try and do some on your own. But when you're ready, I want you to go and try these 4 problems. Pause the video right now, try them on your own. If you need help, ask, and then press play, and I will have the answers for you. So go ahead and check your answers. The first 2 were similar to the examples I did above, where you had to convert them to y equals mx plus b and compare the slopes. This one was a little different. I have these special lines. Remember that anything that says y equals is horizontal. So it is straight across, left to right. Anything that says x equals is vertical. So straight up and down. And so whenever we have a horizontal and a vertical line intersecting, they are going to make 90-degree angles, square angles, right angles, and they'll be perpendicular. For this one, I had an equation, and then up here, I have 2 coordinates that are on a line, and so I need to use the slope formula to find the slope of that line, and then I will compare my answer, which is -3/2, to the slope of this line, which is also -3/2, and that would make those 2 lines parallel. So just a little bit of a variation of how you can compare 2 lines just by looking at their slopes to decide how they're related. If you have any questions on these, please do ask before you move on to the practice. Again, I recommend that you do the practice on paper first. Ask me to check your answers so that if you made any mistakes, we can find them and correct them. When you're ready, start the practice, take your time on these, and good luck.